Okay, so hi everyone. We're starting. Thank you for coming today. Me and Mr. Cleaning Dog here welcome you to this webinar. It's about clean tests or dirty tests and how to clean them. My name is Gil. For those who don't know me, yeah, now you do. So let me talk about me for a minute, because why have you come here if not to hear that? So I'm Gil. I'm a consultant, and I work with developers and testers and everyone involved in whatever uh, things that are software related, agile product, whatever. And I work with everyone so they can basically create better products and better quality code. Um, you can go to my site over here, testingguild.com. It will take you redirectly to everydayunitesting.com, which is the name of my book. This is my first book, and I also have a second book called in writing called Everyday Spring Testing. You can follow me on Twitter, on Telegram, and if you wait for the final slide, you'll see all the ways you can get to me. The examples of code I'm going to show you today are in Java and available in GitHub. In this link, which will be available, GitHub under Gil Zilberfeld, you'll find it for webinar clean tests for people who can't click on pixels in Zoom, but obviously you can download it later. The examples I'm going to show you today are in Java, but the principles I'm going to talk about are universal, even in English. So what else? If you want to know more about these things, you can contact me at gil@testingguild.com, or my partner Tal at testingguild.com. I give consultation and do trainings about TDD, unit testing, automation, clean tests, clean code. So if you want more information, uh, beware of the bugs. For the people who are actually going to survive this and get to the end, I'm going to raffle 2 books, Everyday Unit Testing. I'm going to pick them from the people who are going to be in the user list when I'm finished with this webinar. So keep awake, and maybe you'll hear your name and you'll get a book. It's a free book, so why not? It's an interesting book, and I won't tell you who did the murder. So let's start. Do I write clean tests? Yeah, I try to. We'll talk about what clean actually means in a minute, but we all have a feeling of what clean tests are. We know what they're not. So when we go into tests and we look at them and we ask who wrote this shit, and then we remind ourselves that we did like 3 weeks ago, and we can't understand them, we can't see what they're actually testing, and we know that we, at least today, could have written them better. So it's something that most of us try to do. And basically there are 2 groups of people. There are people who care about clean code in general, and when they write dirty tests, it's because they don't apply the same standards to their tests. The other group is that the people who don't care about clean code at all, and they apply the same standards to their test, which is no standards. So yeah, I bet you had this feeling going into code that you've written before. It would be like 3 weeks or 3 months or 3 years before that, and you look at that and say, this is ugly. Why like this? And that's true for code. And for tests, it's a bit different because we treat tests a bit differently. Although we shouldn't, because code is code, but we do have some different aspects of how we treat test code. And I think it begins with where most people start writing tests. And that would be not the first time that they're writing code. Usually people write code for months and years, and only after that they begin to write tests, because only then they're introduced to automation and testing. So when that happens, it's like after they've written code that works and code that shipped into production. And that means that the test that they're writing, and most of the time when they start out, they think about tests as extra work, non-essential, something that my boss made me write. So they treat tests differently, the code in the tests. So it would be extra, not real code. And apart from that, there's also something about tests that we know in the back of our mind that is not true, but it's kind of is true as we're writing them. So when we pass a test and we move on to the next one, we're kind of not thinking about the last one that we write. We think that, hey, it's passes, so we don't get back to it. We won't get back to it later. So why put some effort into that? And we don't go back to that. And even more so when we're doing test by test, the way we write the next test usually is by taking the code of the last one and mutating it a bit so we can fit the current setup or a different check. And we actually do that and kind of carry our mistakes. I didn't say this. There are, if you have questions, put them in the Q&A panel. I'll try to answer them. I'm not sure as I go, but at least as in the end. So if you have something, put it there. I'll try to get back to it as soon as I can. And basically, like I said, we code test differently, and therefore we don't apply the same standards, although we probably know we should. The session is recorded. I am nice, I think. I am recording. Well, yes, I am recording. So, yeah. So whenever, and for the people who came to the last few webinars, the next slide is going to be familiar. I always get back to what our job is. This is a developer's mission statement, but also for the testers as well. People who are going to touch code, and especially the code of the tests, basically two jobs, not one job. And that's it. The developers need to write code that works, answers the requirements, and so on, and easy to maintain. Now, obviously, tests answer both parts, the code that works, they prove that the code works, and easy to maintain. But if we don't tend to test as the production code as well, we don't apply the same standards to them, the code will not be easy to maintain, because we'll get back to the test and say, what the hell's going on here? Why is that working? What's going on here? So we needed to apply the same standards. So I hope for the people today who came here today, it's not going to be that big of a surprise, but tests are real code. So we need to treat it as real code, and the same treatment we put into production code, we want to put into test code as well. The main thing about maintenance is that most of us don't like to do maintenance. If I do a poll right now about who likes to do maintenance work, I'm pretty sure that at least 95% of you will say, I'd rather write new code and something like that. And when we're talking about being able to maintain code easily, we're kind of talking about reducing the time of maintenance. And we'll talk about what clean code in a minute is. It really comes down to how well do we respect the time of the people who are going to maintain the code and the tests, even if it is ourselves in the future. So when you're thinking about whether we should go back to this code, if it's a question, if it's going to happen or not, we should remember that it's probably going to happen. And when it happens, we're going to work on something completely different, something new, and the test will break, and we need to go back into something that we've written like 3 months ago and remember what we wrote. And we'd like to get this over as quickly as possible. So respecting the future time of ourselves and our colleagues is really about in the basis of writing clean code and clean tests. So I said the word clean like 2 times already. Let's do like a quick question here. What is clean code? Write it in the chat window. What you think clean code is, and we'll see what happens. Make sure that and when you write it, it's for attendees and panelists, so everyone can see that. Clean code is short one. Nice. Like zeros and ones, right? Yeah. What else? Open questions. Make way change, less maintenance. The less maintenance, I think it's the result of that. Easy, well distributed, interesting, understandable, maintainable, and dynamically reusable. Easy to change, easy to read, easy to maintain. Code without unnecessary stuff, readable, easy read, refactored code, well structured, follow solid principles, we'll talk about them a bit, correctly formatted, the formats, generic, no redundancy, easy to understand, read for others, it's for other people, tested code, easy to understand, clean code is the code which was written using practices to make code maintainable and readable. Doesn't need comments. Yeah, I talk about my comments. We'll talk about comments today, but also in clean code courses. And when you actually need them, sometimes you do need comments. Code is easy to read with as less distraction as possible, not spaghetti code, well commented, which kind of negates the no comments part. One that using effective shortcutting, solid naming conventions, help documentation, not too clever. Oh, clever code. I can talk about an hour about clever code. Okay, first of all, thank you for everyone who's written that. Yagni, Kiss, yeah. So you're throwing now practices and techniques at me, which is kind of nice. I feel your love. A lot of what I've written and what you've written and what I've read is qualities of the code and things that we identify in the code, like readable and maintainable, short. These are qualitatives and things that may be subjective, like what is short code? We used to have like a practice that code should be enter in like 20 lines, I think, or something like that, because that was the size of the old monitors. That is what would they've written. And now with graphic monitors, we can zoom in and zoom out, and we can have more or less, and short becomes like something that's debatable. But most of the things that people wrote here is true, because when we look at the code and we see that, we can actually see that we feel good about it or not. So probably some of you have seen this thing. The cool thing about it is that when we're talking about clean code by itself doesn't exist. It exists within the realm of someone reviewing the code. It could be us in the future, it could be somebody else, but it's our reaction toward the code rather than the code itself. when I write, when I talk about clean code in my courses, I kind of bring in some quotes. Um, so Grady Butch, one of the big visionaries around the object orientation group, uh, said that clean code is a simple and direct. It should be written like prose. Prose means you're writing a book. When you're reading a book, how do you understand the words? It kind of feels and it kind of creates an emotion response. So like the WTFs that we saw. So it's simple. It is direct. We understand clearly what it does. Michael Feathers, who wrote, I think, the Bible on unit testing and working effectively with legacy code, said that clean code always looks like it was written by someone who cares. Now, caring about what? Other people, ourselves, our time. So if you look at the code and you say that this is written for someone who has respect for somebody's time, this is written by someone who cares. Martin Fowler also talked about this. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. So we have tools for making the computer understand. It's called compilers, interpreters. You can write in zeros and ones, and if we do our job right, the computer will understand. But for another programmer to understand what we've meant, this is an art. And I always come back to Uncle Bob's Boy Scout rule. Uncle Bob was kind of adopted the clean code metaphor. He wrote a couple of books about the clean code and the clean coder and clean architectures and all kinds of cleaning and maintenance. He always said that always leave the campground cleaner than you found it. Why? Why is the Boy Scout rule? Because we want to respect people's time. We want to respect people who's going to come back into the code. And all this uh, is for other people. And clean tests are also that. So let's talk about clean tests. What makes them cleaner? So I wrote a couple of things. Again, this is kind of subjective because clean code doesn't have a real definitive answer of what it is, but we know this about clean tests. First of all, they show intent. Tests use the code somehow. They show you how to use the code. These are examples of how to use the code, whether it's from unit test to end-to-end tests. People who raise their hand, I can see that you're raising your hand, but I'm not going to stop. Sorry. If you have something to say, please write it in the chat. If it's urgent, if it's not, put it in the Q&A. I'll try to relate, but we need to keep moving. People want to get to the raffle at the end. So tests are examples of how to use the code. And when we're going to read them in a few months, we want to understand what this test actually checks, how it's different than its sibling. And they show intent. If we don't see the intent, if the test is 100 lines long and we can't see the forest from the trees, these are not good tests for us to understand. It is possible to understand what they do. It just takes more time. They're focused. People wrote that code. Code is short, making it cleaner. Well, tests are the same. They're focused. They do just enough. It could be like raising a whole system and running it in a scenario, but we get the feeling of this is what they do. They don't do a lot of stuff other than that. So if people understand, and people who wrote solid in the chat window, solid principles are object orientation based principles, which are also true for functional languages as well, mostly. But and there's the SRP, the S in solid, single responsibility principle, talks about code being focused on doing one thing. So tests, we expect them to do that. Check one thing. It could be something very small. It could be something very big, but it's something, not a list of things. And we sometimes see tests doing that. They do exactly what they say. And if you look at the name, it says the test name is test 13. We're not really sure about what it does. And test names are very near and dear to my heart because I see all kind of funny stuff around them. And we see also things that the description or the names themselves may not be that focused or quite generic. And there's a problem specifically with tests is that when a test breaks, you'll see that not today, because today you're writing it, your mind is about passing this test or something, but three months from now, 4 months from now, 3 years from now, when something breaks and you are working obviously on something else, what you'll see first is the test name. And if it's not clear enough what actually failed, you now need to uh, kind of build the whole puzzle again to see what it actually does. It starts with the name. The name is the first breadcrumb that you have when the build fails. So good names that direct you to what the test actually does and where the failure was, very important. The final thing is a kind of a thing that I see a lot happening, or a lot not happening. And today, tests, but also code is built on top of frameworks. I'm going to show you examples from Spring, but a lot of the setup that we do, just making the tests run requires a lot of bare bone framework code that we just needs to be there. And we see this code copied over and over. And yes, it needs to be there. It kind of distracts us from what the test actually does because these are implementation details. And good tests abstract the details. If I want to know the details, yes, I'll dig deep and I'll see what happens there. But if they're just in front of me, like the example I'm going to show you soon, they're kind of distracting and they make a lot of noise. Now, probably some of you know about code smells. Code smells are anti-patterns in code. And the reason they're called code smells is that there's not a problem with the code, it is a potential problem with maintenance for the code. So, and the same applies with tests. You can look at the patterns in the code when you identify them, and you see, well, these things are probably going to be a problem for easy maintenance later. The ones I'm going to talk about or show you today are God classes and methods. These are the big chunks of code, and you can see them in the tests. It's a bit different with tests because we have like test classes and test modules and test methods, and they kind of build up like, what is this doing? It's testing a component, great, a controller or something like that. Let's stick all the tests in there, and we get to 10,000 lines test code. And we don't know what's happening, and we're not sure if the next test that we're going to write needs to go in there or somewhere else. So we stick more in there, and this kind of thing build up. And it's a problem because when we actually look for stuff in there, we might not find it. It's like a big garbage can that picks up all over. Comments, I'm going to talk about them, and comments and their siblings, uncommunicative names, can leave an impression of you of what's happening here, while it may not be the right thing. And I'm going to talk about embedded constants. When you see a test that it says user ID equals 17 in the setup, what is the meaning of 17? Is 17 a special user? Is 17 a number that I have to use, but 18 would work just as fine? What are the literals meaning? They're special, or could there be any value out there? And I'm going to show you something that may even improve the test in terms of stability and fragility. So, demo. Like I said, it's going to be in Java, but what I'm going to talk about basically appears everywhere else. So our code, like every time I do a webinar, I complain about calculator examples and then show them. This is no different. So what we have here, I'm going to talk about API tests, REST API tests in Spring, but like I said, it could be like unit tests, it could be end-to-end, could be whatever. Principles are the same. What do we have here? We have a controller with an API called calculate. It gets a body in forms of JSON called calculator params. Calculator params has basically 3 arguments: first, second, and operation. The operations are, of course, plus, minus, mul, and div. And our calculator, basically what it does, it takes the plus, takes the sum of the first and the second arguments and turns them into a string and return it. The minus subtracts them, and everything else return an error. Not great code, I know, but we're going to talk about tests today. Actually, this is great if we compare it to the tests. So let's start. What I'm going to show you is basically things that I see all the time. Okay, so 3 tests, just 2 for the sum, 1 for the subtraction. We have a comment and test add, which we already see as not a good name, probably. The case is I'm doing 3 plus 4. And then I have all kinds of framework stuff in order to do the post. I'm also looking for, I'm running on a local server, and I'm calling the root API, the calculate, and I'm expecting the results to be 7. Which is nice if it was the only test here, but unfortunately I have 2. So this one adds 2 negative numbers and basically looks the same because I copied everything, and except for these values here. And then we have something here, which 20 minus 4. So you'll see a lot of things about this that kind of bother you because you would have written them differently. So I want to take you with steps about the things that I went from something that like this into something that I could live with. The first one is obviously remove duplication, but I'm going to use the setup module. I'm using JUnit here, and a setup method like before each. In JUnit 4, it's called before method. Any framework of fixture that you'd write a test fixture with will give you something like that. What I did is two things. First of all, I didn't have fields. I moved them into the class. So now they are defined here and initialized inside the setup method. Everything works the same, but we are all the new stuff is not repeated. So we're going down from something like 100 lines of code to something like 90. Everything I'm doing here you probably know, but people just don't do that. And I want to make sure that when you come back to somebody else's code and review them, ask them, why didn't you do that? Okay, so that was the first thing. The second I did is talk about the naming and the description. So what we have here is basically, let's look at the first test. It adds 2 numbers, right? Yes, I call it test add because everything, it doesn't really. But sometimes in some frameworks needs to start with test. In JUnit, since version 3, you don't. So let's see the comment. Check that we can add 2 numbers and return the right result as a string, which is basically what it does. Let's look at the second one. Well, first, add minus is kind of a non-English thing. We kind of add two negative numbers. But when I copied the stuff here, I also copied the comment. It's still true, but it doesn't give us any more information, and we can actually do that. And I actually failed to copy the comment from here. And you'll see short names because sometimes we start off with a test ed or something like that, and then test and kind of need to specify more cases, but we need to be a bit more elaborate with that. And I'd like it to be more English. Now I didn't go the whole thing here. I kind of removed the comments, put them into the names a bit more, add two numbers and calculate results, add two negative numbers and calculate results, subtract two numbers, calculate results. I could have gone a bit more, but I got rid of the description, the comments, and put a bit more details into the names. I want to warn you about something that happens a lot, is that when we're starting to write a test, we go in one direction, but then we kind of take a left, but we forget to update the name. So we have a direction we're going in, so we put it in the name. So we're going to test that, but then we write code which is a bit different because we kind of took a left, and the name doesn't describe what we took in the end after, and we don't get back to that. And that's a problem because we want to remember what we did like 4 months from now. So we'll have something conflicting, and the test will break, and we'll say, well, something's wrong here. Should it pass? Should it fail? What is it testing? So as part of your review, we actually need to look at these things as well and make sure that the tests are coherent. Okay, so let's get back to the application because it's still there. So what we did before is that we talked about extracting functionality into something. So the first step was to put them in the setup, but obviously we have a lot of code in here that repeats itself. And that's the boilerplate code of doing the post itself. You can see that basically it's the same thing, right? We're taking the body, turning it into a JSON string, create a request, calling the post with the same with the same URL actually, and then asserting that on the result that we got. So basically this code can go into a function. Let's do that. We call it call calculate because it calls the calculate API. So pass the URL there, and we have a call calculate here. Notice that when we did that, like the test like shrink into something that contain just basically what is different about the different tests. And that's what we'd like. We would like them to look at them, and when the test, when, for example, this one breaks and this doesn't, we say, well, what's the difference between these two? And we'll see just the difference because this will help us solve the problem better. So extracting stuff really reduces the noise. Zoom is not okay. Oh yeah, okay. Don't confuse me. Okay, so extracting that makes sense. Let's see what else we can do. So you see that I'm actually repeating the string here, right? So let's take two steps here. First of all, I'm going to do what we called extract constant. I'm putting the local URL here as part of the class, and therefore I don't need to pass it as a parameter here. Now call calculate doesn't need a parameter. It just uses the URL here, which is cool. But let's go something a step further. If you look at my controller, you'll see that the complete URL and the complete URL of the specific API are part of the production code. I put them in a const file. So if they're here, I can use them as well, and that makes the test less fragile. So I'm kind of separating the stuff. I'm keeping the test part, the thing that's being part of the test. It's run on the local host here, and I'm concatenating the parts from the production code. So if the production code changes in terms of root and where the API is, the tests will be affected because they will call the same API. And that's cool. Okay, let's see what else we can do. I talked about abstraction and how this code in particularly is boilerplate and so on. So let's see what we can do. But before we get to that, let's talk about another type of abstraction, and that's the data. It's cool when you have like 3 parameters, but if you had like 20 or 50 or 100, you have to build like a giant JSON stuff. Obviously, if you fill this up in the test with every test, you won't see anything because you'll see just big giant setup. So probably most of you know about the builder pattern, which is used a lot. So that's what I did. I created a calculator param builder, and it has a second and first and opt. People who don't know about builder, basically the builder pattern is a factory pattern to create stuff for you. You use it a lot in tests because of scenarios like this. The setup takes up too much, or you want to compare results, setting up the result takes too much, let's call it even a real estate of the test itself. So we want to hide it and we want to create it, but not just create it. We want to make it a bit more readable and sometimes hide stuff. Now, the builder here, basically, it's an object that could be even part of the production code, but we're using it as part of the test itself, because the production doesn't need it. So we have with first and with second, with ops, the way builders are usually built are in a pattern called fluid interface. They return themselves, and they finally end up with the word build, which kind of builds the stuff with everything we stuck into that and create something for you. Now, basically, if we look at the test and we see it's basically the same, but I got rid of building the params. I now have a param builder here, and I'm using param builder with first and with second and build. What you don't see in the first 2 tests is telling what I need to tell the calculator params that this is with the plus operation, because I put it as a default here. Putting defaults in the values make sure that I don't need to repeat them in the tests. So going back here, my first and second tests like this will not tell you with which operation I'm actually building. I might even change the name of the param builder here to something like header or something like that. But in the last one, I need to specify something different. And again, this goes back to I want to have whatever is different in there. Yes, there's a downside. In our case, the 2 first ones actually rely on having the plus sign. And we kind of hide this detail because it's a default. But we can play with that. We can play with the defaults that we want to hide completely. We can specify them also here and tell the test or the reader of the test, yes, this is important. Or we can decide not to. And I decided not to. Now, the final thing I want to do is get rid of this. I can't really get rid of the boilerplate. It actually does something. But if you look at it, you'll see that it's kind of a generic thing, right? This one works with calculator params, but it actually does create a request and does a post with a URL and returns something with a string, kind of a generic thing. So why not build an API call wrapper that does this? So all the boilerplate stuff goes here, the headers, the REST template, the object mapper, everything that is mechanics, implementation, and basically the test don't need to know about. Or for us, that the tester reader does not have to know about. If they want to, they'll go in, they'll see what's happening there. But basically, this API post with body, which now gets an object, and does exactly the same thing, is now generic and can be used and probably will be used in other tests from the same class and probably others as well. So extracting implementation and putting it in a central place with a utility class or something like that reduces the size not only of my tests, but also for other tests as well. And let's look at what we've got, the final version of that. So setup is smaller because now the boilerplates in the other class. And what I did is the test remained the same as we wrote them, and the call calculate, which is test specific for my calculator, uses the generic API call wrapper. And I separated again things that are test specific and those are generic. And by doing this separation, my tests become much clearer. And whatever layer I'm looking at, the exact test or the test class, a lot less code. I understand the intent. I understand the difference between the tests, and the principles apply from unit tests up to end-to-end tests. Like if you're doing, if you're using the page object pattern in end-to-end tests, you know about abstraction because the tests look a lot clearer because they don't deal with the mechanic of dealing with the Selenium, the WebDriver, for example. The abstraction also abstracts details for filling up things in the form that the test doesn't need to do. So the same principles of removing the application, showing intent in the code, removing noise and abstracting it into separate places. If you do that, tests will look a lot better. And now I'll get back to my slides. So we did a couple of refactoring, and these are no, and again, this I'm not telling you something new. I'm just telling, take notice of that. If we don't treat the code and the test code the same, and when we review the code, we said you should have extracted that. But when we look at the test code, we don't tell the person you need to extract that into a separate module. We don't apply the same standards, and we don't get the same result we'd like from the production code and the test code. And when we do that, time gets wasted. So these smells can be refactored back to nice code, clean code in the test. Code classes and methods, you see how we reduced our test code and our tests into smaller bits to contain the important stuff. We removed the comments. We used communicative names telling us what to do. And the literals we used, we kind of used them in our example a bit more directly, whether it was the test code and what is the production code. Another thing that I do sometimes, if there are defaults that I need to set up, like the 17 user ID is 17, I sometimes rename it to a constant that says any user ID. And when people read the any user ID, they know they can replace it with 17 or 18 or 19, and it wouldn't matter. But if it says specific user ID, they know this one matters to the test. So by keeping the names, we can actually direct the reader to what is important in the test and what is Basically, it may be important to pass the test, but not for the test itself. And if you follow these rules, these principles, we're kind of getting better, fresh, clean test smells that we'd like from our tests. Because if Yoda is happy, everyone is. And that's basically my plea to you today. Test code and production code, we should treat these things as the same thing. We should have the same standards. If you don't have standards, that's fine. You're already there. Good luck. But if you have standards about your code, apply the same to the test code. That means writing it in the same with the same principles and reviewing the code and the test code with the same principles. And when we get stubborn about following these principles, both in the tests, and don't just let people push in test code because it doesn't matter or it's not as important and so on, we'll actually get the result that we don't want, which is dirty tests, which I just told you how to clean. And that's my story for you today. If you'd like to know more, if you're interested in courses that I do about clean code, clean tests, TDD, automation, whatever, you can find me there. And in the last slide, contact me and so on. And now I want to thank everyone. If you have questions, put them in the Q&A tab, which I will open ceremoniously right now and see what happens. Let's see what happens. So is it possible to see I wrote conventional versus how I could have written by TDD? An example would be great. Okay, I didn't mention TDD. Obviously, I won't see examples today, but if you follow, the next webinar will be about TDD as well. Code will be different. Code is different. When I write with TDD, and it doesn't matter if it's test first or like API tests or unit tests, code of the test looks different. And it will keep the same thing. It will be shorter. It will show intent. It will not talk about implementation details when I write test first. Why is that? Because I have, with my Supreme experience, already following these principles as well in the test. TDD doesn't make you write better code, but if you experience with design and writing tests, your tests will seem different. Now, if you have this experience, it doesn't say that you can't go back and write tests the same way. But TDD will, following this principle, kind of, if you've kind of internalized the principles of how to write in when you're writing TDD, test will actually look a lot better, and you'll see a lot less noise. Specifically when you go to the second test, because what happens on the second test is we kind of copy the stuff from the first test, and we have noise in the first one, we have noise in the second one as well. So it doesn't say that TDD means that it will be better, but if you follow the actual principles in TDD, which I'm going to talk about in the next webinar, by the way, your test will probably be better. Okay. Clean code where you do not, that was an answer on the clean code thing. Thank you, Marty, Andy. Usual code review is done on general standard like ESLint, which also developers use. Are there any specific review tips for testing? Okay. Static code analysis doesn't understand your tests. So when you go to reviewing tests, you need to go in like a person. It's going to be your time. The person's going to go into the test and find out what's wrong. Why did it break? So you need to understand the test. If it's not understandable, you need to clean it up, like things that I did today, but it has to have the right name. It has to be short, understandable, and so on, like we talked about. It has to be similar, but not completely identical to other tests, because if one test checks the if and another one checks the else, they need to show the difference. And you want to see that, because if you don't see it now when you're talking to the person who actually wrote it, in a few months when you're in charge in there and you're the only one, chances of you getting the right answer there is a lot slimmer. So everything about clean code, we want to apply to clean tests, but make sure you understand it. Make sure the tests show the intent, and the test names show what they're doing. You see from the tests what they're doing and how they're different from their brothers and sisters, and remove all the noise and the boilerplate. Will I send out the recorded webinar? I'm going to post out where it's going to be. It's going to be in the site, of course, and on the YouTube channel. I have a YouTube channel where every video goes, so you can check that as well. Any other questions before we sign off for today? Last chance before I go get my second coffee cup. Okay. Thank you guys for coming here today. Appreciate it. Next webinar is going to be, like I said, about TDD and TDD and API, I think. So hope to see you there as well. And have a nice rest of the day. Bye. Bye. And someone said it was still awake. Cool. Got one. Excellent. Bye, everyone. Hey, everyone. If you enjoyed this video, be sure to like, share, and subscribe for more. Thanks for the support, and remember, live long and test.